Hi, welcome to the Unit 1 virtual unit preview. I'm going to go through the unit plan with you today. Essentially, this unit plan is the start of the entire course of geometry, and it really sets up how to name things in geometry, understanding the difference between a segment and a line, understanding how to name angles, find angles, etc. So it's only 6 class periods long. It starts on August 14th. You might have a day or two before during Culture Week where you might opt to start the unit early. But Culture Week officially ends and this unit officially begins then August 14th. But that's up to you and how your campus decides you can do that. But so 6 class periods long, it's pretty short. The global context for this unit is scientific and technical innovation. So they'll come into geometry with a basic understanding of how to perform math calculations. They might not understand the purpose of math or how it was developed, and so we're going to look at that during this unit, essentially looking at geometry and math as an explanation of the world around us. Extremely applicable. And they'll start to make those connections as their own too as the year progresses. The unit's purpose is to introduce geometry as a way to make sense of the world around us and to reveal just how logical, relational, and reliable the language of math is. That's going to be a theme that I want us to focus on during this whole year, just so scholars don't see math as something that they learn and experience in your classroom, but rather something that they can experience outside as well. I want them to start making their own connections and seeing streets as parallel lines and understanding that a shortcut from point A to point B would be the hypotenuse essentially, or things like that. So scrolling down here in stage 1, the inquiry and purpose, we're going to look at logic a lot this unit. We're going to introduce the logic statements, which are going to be crucial. Students might be confused why we're learning logic this unit. So what I'm talking about is conditional statements. So if the animal has stripes, then it's a zebra. Okay, so then evaluating, is that true or is that false? Of course, we're going to apply that to geometry, but that's just an example of what we're talking about with logic. But they're going to use logic in all areas of their life, and I think for a lot of scholars, it's going to be a nice break for them from plugging and chugging, from solving equations. Just looking at those logic pieces might help them a lot understand that math really is a whole lot of thinking and evaluating and kind of deciding if something is true or false, taking known information and making conclusions from it. So that's going to be really important in this unit. Justification is going to be our related concept. Scholars need to be able to justify each of their mathematical steps. They need to justify why this angle is angle ABC and not angle ACB. And that's just simple examples, but these are the types of things we want our scholars to be thinking about, and we want them to be able to justify every step of the way, ideally. Statement of inquiry. This is going to be really important, a huge theme, and you guys are going to have a lot of autonomy essentially on how to incorporate this statement of inquiry. But we can expand our understanding of the world through logical reasoning. Lots of different ways you can take that statement, lots of different ways you can have the kids talk about it, think about it. Essentially, I just want the focus to be that if we start looking at the world through ifs and then statements, things like that, it's going to help them make sense of the life that they're living, the things that they see, the subjects, the concepts that they're encountering in school. Moving on to the inquiry questions, you'll be able to see the factual, conceptual, and debatable questions. The factual questions are things you should be asking. Of course, not every one of these, but you should be asking every single day in these lessons. Conceptual, same thing. You should be asking these every single day. This is just basic teacher questions. Do the students understand? You can use some for CFUs. You can use some for just natural questions. It's very natural to just be asking questions. Why? Why do you know that? How do you know that? What if this? What if that? And that's going to help the students get to these answers. The debatable questions, on the other hand, are supposed to be questions that we can ask in a math classroom, but are not necessarily geared toward a math classroom. So the first one, is it helpful to our peers to prove truth or falsification, and why? The second one, how is reasoning different based on one's perspective, culture, and experiences? I think this is going to be really important, this second one, for scholars, especially as they're starting high school, or maybe in their second year of high school, or maybe in middle school, is they're going to approach conflict, or come in conflict with one another. And does that make one person wrong and one person right just because we come from different perspectives and cultures? How is our reasoning different? And we can talk about that in math very easily. Why did you set up the equation like this? And why did someone else set up the equation like this? And how are they both right? Or is one wrong? These debatable questions are going to be important to focus on this unit. Might not be every day, it might be every day, but there should be at least a hint, at least the question should come up every lesson. Moving down into the content, you have a list of the TEKS. The bold TEKS are the readiness TEKS. We have some really important vocab. I'm huge into vocab. I always make my students say words correctly. It is a segment, not a line. Or it is a line, not a segment, etc. It's an angle, it's a vertex, not a corner. Things like that. Knowledge and skills, scholars will know these things and they'll be skilled at these things. You guys can read those on your own, and if you have questions, go ahead and contact me or reach out. But I'm going to move on here. Interdisciplinary connections. These are examples of how you might want to connect this unit with other courses that your scholars are taking. So in English, a really easy way is that math is a language, and it's structured, creative, and specific. Just as there are punctuation rules in English, there are notation rules in geometry. I think that's going to be a really easy connections for the scholars to make. You can't put a comma at the end of a sentence. You put a period or an exclamation point. In geometry, you put a line over AB if the segment is AB. You put a line over it, not an arrow, etc. In art, things change and evolve throughout the ages. What we think is beautiful. You can read this on your own, but essentially it's just talking about how trends change and how a lot of that has to do, like you can see geometry in all of that, how curves were once beautiful and now, straight, symmetric lines, modern houses, things like that. Just how the geometry of trends has changed. In science, we observe, guess, test, and conclude. This pattern is repeated over and over again until truth is revealed. Just as science is an explanation of the world around us, so is geometry. Science is essentially applied math. We'll learn how mathematicians throughout the ages have devoted their lives to this truth-unveiling process and also participate in this process ourselves. How will these connections be executed in the unit? You guys can read this yourselves. Essentially, this is going to be up to you how you execute it because you guys all have your own flair. But that's just an idea for you in that paragraph. All right, moving on to stage 2. We have the performance task and assessment. In this unit, it's such a short unit, they're only going to be assessed through a unit test and a short essay. And you guys can pull up the unit test, it's on Blackboard. The connection to the statement of inquiry, the test will feature problems that require students to make logical arguments. There is one question specifically in the test, it's at the end, you can see it, it's a short answer question where they're going to have to take essentially some riddle, some combination of logical statements, and they're going to have to figure out what's true and what's false. It's actually a quite difficult question, essentially error analysis. The resource for that is at this link if you guys want to check it out. I just found it and I thought it was difficult and a good way for students to start thinking logically about something that's not necessarily geometry. We can test their logic in this way. Throughout the test, they are tested on logic, specifically geometric logic. It's just criterion A for the MYP criteria for the unit test. All right, if you have questions on the test, then just let me know. But the test is on Blackboard. You guys can check it out. All right, stage 3 is backwards planning. We're going to be thinking a lot this unit, especially because we're looking at logic. That involves a lot of thinking, just slowing down, evaluating a statement. Is it true? Can we rewrite that statement, and is it still true? Okay, lots of thinking. Some scholars love learning logic, and some scholars don't, just because it's just kind of an odd thing to learn in math. I don't think that they ever have done a unit like this before in their math education. Learning experiences and teaching strategies. I go through each of these learning experiences and teaching strategies. You guys can check these out. This is differentiation. If you don't understand what I'm talking about, like here it says hand-arm gestures to represent angle pairs. I'm saying, like, for vertical angles, put your arms into an X. Make your arms an X, and there's vertical angles. For a linear pair, one of your arms can be the straight line, and one of your arms can intersect the line so that it cuts that line into two parts. If that's confusing, I know, like, you can't see what I'm doing. So if that's confusing, just reach out and I'll help you, and I can, like, take a picture and show you or something. But that's the same with any of these things. If this does not make sense, then please reach out. Differentiation. This box is not supposed to be like a catch-all. You guys have IEPs to follow, so make sure that you do that. But this is just on top of all of the other stuff, extra suggestions for how we can differentiate our teaching to meet all different sorts of scholar needs. Okay, this Frere model note cards, I'm just going to say this, look it up if you don't know what it is. You can modify it. Essentially, these note cards are 4 different boxes with a term in the middle. Those boxes you can change. It can be a definition, an example, a non-example, a picture, however you choose. But Frere model note cards are fantastic if you use them correctly. Formative assessment, you guys are going to have daily exit tickets included in this unit plan. Quiz prep homework on Blackboard, mini quizzes every 3 lessons on Blackboard. This is the way I set up my classroom. I think it's a great way. I've done this for a while. If you don't like doing mini quizzes and quiz prep homework, then that's cool. You guys can decide your own way to manage your classroom and homework and quizzes and things, but that's just how I do it for me, so I give you the resources online on Blackboard. Real-world connections. We can start talking about, I've already mentioned them a little bit, how geometry is a tool for investigating and modeling problems in the real world. So we're going to be looking at language and notation as critical for communicating. We're going to look at logic statements, how to decide if something is true or false, how to understand the angles, maybe in architecture or landscape architecture. How do certain angles play a role in building a structure or designing a garden, things like that. You can come up with your own real-world connections based on your own experience and what you think would be interesting to you and your scholars. Here's some ideas for resources if you need more resources. Otherwise, reach out to me. I have so many resources. I can share anything with you. All right, moving on into it. Day 1 is huge. This is going to be a huge day for everyone, learning what a segment is, a line is, what points are, an angle, a vertex, a plane. This is so important. You cannot move on from this day without scholars mastering geometric notation and understanding the difference between all of these terms. You'd be surprised how many times you go over how to name an angle throughout the year, and by the end of the year, somehow there's still 1 scholar, 2 scholars that still are so confused on how to name an angle. So catch as many as you can during these first couple class periods so that does not become an issue. Really drill this lesson. My suggestion from experience. Day 2, I really love this day. I really get excited and pumped because for whatever reason, I have a favorite angle pair, and that is vertical angles. My scholars just think it's like so geeky that I have a favorite angle pair. And so I really hone in on that, and I get all excited and I stand up and I clap and I cheer for vertical angles, and every time some answer to a question is vertical angles, I get all excited. So that's just something that's really silly that helps students remember vertical angles in my classroom. You can put your own flair on these things, but understanding angle pairs is going to be crucial. You're going to see linear pairs, you're going to see vertical angles, right angles all throughout the year. So if they don't understand them here, again, they're going to be lost later. So drill this lesson. Moving on to day 3, we're talking about bisectors. I think it's important for you to go over that there's like a difference between a bisector, bisect. There's a whole bunch of different forms of the word. And so if I say bisect, they think bisector. So just go over that to bisect, like bisect is a verb, bisector is a noun, and what the difference between using those words are. Again, this is vocabulary, nailing vocabulary, and making sure that students are speaking geometry correctly and understand what they're saying, of course. Moving on to day 4, we have logic, okay? I highly suggest in day 4 that you use simple statements, probably that don't have to do with geometry, to teach these converse, inverse, contrapositive. For example, the one that I gave you earlier is if the animal has stripes, then it's a zebra. Is that true or false? That's a lot easier to understand for students because they know what a zebra is, they know what stripes is. That's easier to understand than the statement, if the angles are congruent, then they are vertical angles. Well, that's kind of fresh to them, and so you might not want to teach these logic statements using geometry vocab quite yet. You can maybe by the end of the lesson, depending on how your scholars do, but I would definitely suggest starting this lesson with using very familiar topics to the students. Lots of different ways to teach this. Some scholars really get into it and they get really excited. I like to do a stand up if it's true, sit down if it's false, type of interactive lesson for these converse and inverse statements and contrapositive, just because it can get boring. So try to make that one as interactive as possible. Day 5 is talking about validity of converse, inverse, and contrapositive. I guess if you don't talk about the truth value up here, I just said that I did stand up or sit down if it's true or false, then you can do that activity here. Counter examples are important. A lot of times students want to say, if I ask them what is a counterexample for this statement, they'll give me this long sentence of an explanation as a counterexample. I'm like, hold up, a counterexample is a thing. A counterexample could be a cat. A counterexample could be a chair. Like a counterexample is not a sentence, it's not an explanation, it's just a thing. So just make sure that you kind of drill that, because counterexamples can be confusing for students to understand. Truth value, you're going to want to use simple statements to understand these truth values, and logically equivalent statements. You can do some sort of investigation with the logically equivalent statements, just so students can reveal those logically equivalent statements themselves. Day 6 then is the exam. You can see the Blackboard site for the exam, and then we get into the reflections at the end. I just kind of put my own 2 cents in here in this first box, just to give you an idea of my thought process as I was creating this unit plan. While you're teaching, and then after you're teaching this unit, please fill these boxes in. It will help you understand your scholars better. It'll help you be a lot more reflective and engaged in teaching and understanding how your students have learned these lessons, what kind of was missing, how you can change things in the future. So please fill this in along the way. It's going to make you a better teacher in the end. All right, so this was the Unit 1 virtual unit preview. If you guys have any questions at all, please reach out.